Now let's look at an integral where both the upper and lower bounds are infinite. Okay, so what we're going to do is just break it into two parts. So, and I can pick any point in the middle. You know, I could pick 10 or I could pick negative 13. It doesn't matter what I pick, but I'm just going to pick 0 because it's easy. So I'm going to integrate this from negative infinity to 0, 1 over 1 plus x squared dx. And I'm going to add the integral from 0 to infinity of 1 over 1 plus x squared dx. Okay, so I just have to do two parts now. So I'm going to just start with the first one. Okay, let's integrate, take the integral from t to infinity, or to, not infinity, to t to 0, right? Because since negative infinity is my lower bound, I'm just going to integrate it from t to 0. 1 over 1 plus x squared dx. Okay, now you might recognize that. This is one that you should be able to do just by recognition, and recognize that it's just the arctangent of x, and we're going to evaluate it from t to 0. So we end up with the arctangent of 0 minus the arctangent of t. All right. Now the arctangent of 0, if you look at arctangent, it's essentially, you know, kind of it looks like tangent only laying on its side, right? So we have these asymptotes at pi over 2 and minus pi over 2, and then it looks kind of like this, right? So let's just keep that there as sort of a visual. And so the arctangent of 0 is 0, and so what we end up with is just minus arctangent of t. All right, so we can take the limit as t goes to minus infinity, right? Because that was our lower bound that we set to t, of the minus arctangent of t. And so if we look at what the arctangent function looks like as we go to minus infinity, it's approaching minus pi over 2, right? We're going this way, right? So we're going to minus infinity, so we're approaching minus pi over 2. So it's a minus pi over 2, right? So the minuses cancel, and we get just pi over 2. All right, so we've done the first half. Let's do the other half. So we're going to take the integral now from 0 to t, right? Because now we're integrating from 0 to infinity, so we're just going to set the infinity, the upper bound to t, and of 1 over 1 plus x squared dx, okay, which is again just the arctangent of x evaluated now from 0 to t. Okay, so we get the arctangent of t minus the arctangent of 0, right? And the arctangent of 0, just like we said before, is 0, so we just get the arctangent of t. And we're going to take the limit, too many humps in my m there, but back it up. All right, let's make it look nicer. Limit as oops, not x. Gosh, I'm having trouble. All right, we're going to take the limit as t goes to infinity of the arctangent of x. All right, and okay, let's go further back to our drawing of arctangent, and now we're approaching minus infinity, or sorry, approaching positive infinity, so we're going this way. So that's just going to be pi over 2 again. And so now the integral from minus infinity to positive infinity is just going to be the sum of those two things. All right, so integral from minus infinity to positive infinity of 1 over 1 plus x squared dx is just going to be equals pi over 2 plus pi over 2, which gives us pi. So hey, we just we just did an integral from minus infinity to positive infinity and got a finite number, and we got the value of pi. So that's very cool. All right, so let's. I'm going to go on. That takes care of our discussion of this type 1 of improper integrals where we have infinite intervals, and now we're going to look at the type 2. So I'll meet you in the next video.